And we are live. Yes, Wim Dijkgraaf here, Quotation Factory. The seventh live stream about the topic smart factories. In Europe, also known under the political name Industry 4.0. Quotation Factory, what we are specialized in is a cloud platform for metalworking companies in the segment of high mix, low volume. And what we help them with is reliable estimations. Three types of estimation: production time estimation, material usage estimation, as well as lead time estimation. And why Quotation Factory? Because those three estimations are critical as part of the quotation process, as well as for the whole planning and work preparation process. Part of our cloud platform is what we call the Edge Connector. So we have a cloud platform that connects with the local factory infrastructure through industrial IoT technology. That's the basis, for example, to integrate the cloud platform with the ERP system and with the CAM systems. We have an important team, the customer success team, that helps all of our customers to further improve and continuously improve the reliability of the estimations. And what we see now is that more and more of our customers wish to be able to observe the actual shop floor as well as the outcome of simulations, and therefore by observing that they can feed that information back into the cloud platform in order to automatically identify where the estimations are not reliable enough because, for example, they are over or underestimated in relation to what the CAM system has estimated or what the actual machine has measured. So therefore, we are helping out with our customer success team customers to really connect machines and CAM systems to the platform. And that's the way we create a closed loop system. In my last video, I spent roughly an hour to explain the difference between an open loop system and a closed loop system. Our customer success team, consisting of 4 people, are experimenting with event-driven architectures, with industrial IoT, Internet of Things, as well as with all kind of devices and sensors, etc. So I invite our customer success specialist, Lenn Hoek, to the live stream because he's going to show what I call sexy or inspirational use case. So there we go. Lenn, welcome.
Hey Wim, thank you for having me again. So
yeah, the floor is yours.
Thanks. Ready for the
no idea
sexy
what you
use
are going to
case.
show me, so I'm already.
We have something in the screen. So. Yeah, that is giving you some idea what might be going on. So what you see is a machine state indicator light. I will tell you more about this in regards to my case. Quick introduction, as Wim already said, I'm part of the customer success team. If you want to know more about me, you can watch the previous session, which is also a little bit basic for this session as well, because we talked about unified namespace. And of course, the sessions that Wim also did solo. So for today, Wim asked me a few months ago and some other colleagues in the team, guys, I want something that we can demonstrate unified namespace, Industry 4.0, the use of microcontrollers and sensorics in and for the factory floors of our customers. So we took the challenge and we said, let's build something. So I will just share my screen and I'll take you through what we did in a small presentation and a demo. So should be.
Yeah, Len, in the meantime, so what we have
Yep.
demonstrated up to now was based on simulators and software only. So what we have shown in the previous streams is what is an event-driven architecture, what is specific to unified namespace as a type of architecture. We have spoken about OPC UA as a protocol to connect machines, the role of, for example, MQTT as a protocol, as a standard protocol to connect systems and logic, etc. I think this time it will be the first time that we actually show hardware being integrated by using small microprocessors like an Arduino type of architecture connected to an event-driven architecture. Is that correct?
Yes, and we also have some machinery involved that you will see later on.
Oh.
So some personal hobby of mine that I'm also doing, which I integrated. So in that case, the why, as Wim always says, you have to build it to understand it. Yeah. So this was main thing. Just go and start, build something, and then you will really understand what you are doing and what the challenges of our customers might be in the near future. So he said, build something, a basic automation concept using event-driven architecture, protocols and standards that Wim already touched, using the open source, easy to use software and hardware like Arduino and cheap sensors, and preferably somehow related to manufacturing. And therefore, we have the status lights that everybody knows. So what is the concept that I will be showing you guys? I, in my personal time, also do a lot with 3D printing. So we have on the left side a 3D printer, and this 3D printer can communicate through MQTT with our namespace. And this printer has different states where it's operating in. And based on that state, we can influence what color of lighting is used, so to indicate the state of that machine. And secondly, also to make the demonstration a little bit broader than just showing what state the machine has visually by the use of the lights, I'm also going to influence the process with a sensor that is also, and everything is connected through the unified namespace. Using MQTT as for publishing or subscribing. So as you can also see, the 3D printer is doing both, publishing and subscribing through the MQTT protocol, whereas the machine state light is only subscribed and only changing based on the state change that the 3D printer will publish. And we have the DHT20 sensor, which is also publishing the status of temperature as well as humidity. So, and on the left side, you have a little bit of view of the namespace that I have running that we will also view in the demo. And that's what we're going to do next. I'm going to show you how it works in real sense, where you will see the machine moving, you will see the lights moving, and you will see as I blow on the sensor where a lot of humidity is created, that the process will be canceled. And this all through the use of software of Bamboo Lab, which is the machine, Mosquito as my broker, Node-RED as my interface, and we can see the data flowing through the broker using MQTT Explorer. So,
and just to make sure, because Bamboo Lab, that's new to me. Can you explain that just a little bit?
Yeah, this is the brand of the machine, the 3D printer I'm using, which Bamboo Lab is, it's a Chinese brand of machinery, I think, which makes for the hobbyist, semi-professional use, very competent machines. So,
okay, nice.
And it has a software which you can connect to the interface of the machine remotely, where you can also watch the machine. So that's what we will do in the feed later on. And the interesting thing there is that Bamboo Lab is really taking off on the Industry 4.0, and it is making its machine MQTT native. So there is a broker actually running on the machine to do automation, which is also quite cool. So let's have a look, I would say. Any more questions, by the way, Wim? I'm going to be switching.
To me.
All right. So here we have the Bamboo Lab machine. I'm just going to connect. So this is the inside of the machine that you'll see. This is the print head. It's the white thing on the left side. It will start moving later on as soon as I start the process. And what you will see also is that the indicator light will indicate something differently, where orange is the state for being idle, green is running, red is error or cancelled.
Okay, so you have a live stream of a video camera?
Yep.
Because that machine is not in your current location, in the room that you are in now.
It is in my room, so it's next to me, but it's difficult to place my video camera and stuff inside of the machine. So therefore I'm doing it like this. Yep. This is a software that you use. It's like a CAM software where you prepare the part. So we'll quickly do the preparation. It's a little clamp for a cable, which you see here. That's the black thing that we're gonna manufacture just for fun. So I'm saying, hey, I sliced it, I made little layers of it. Now I'm gonna print it. So I'm gonna send it to my machine through the cloud, the part itself. So let's start sending out. And as soon we will see something changes within the lighting, we're gonna connect through the camera. As you see, the state light is changing from orange to green. And as you can see, some data on the left side, and the middle is, the right side is that there are some parameters changing. So the machine is heating up because we need to melt plastic. And it's doing some other activities. And if we're correct, the machine should start moving any second now. And I can also, yes, there we go. So the machine is now starting to calibrate, heat up, doing its thing before starting the process. And as you also can see is that we have some data flowing. So the alarm light has status 1, which status 1 indicates green light. I will later on explain how everything on the electronics and the microcontrollers work. So as we can see, the humidity is currently 46%, and as I will be blowing on the sensor, as you can see, the humidity will rise, and when it will rise above 65%, there will be a cancellation of the process. And we can also see it in the machine interface over here. So, and there we have it. So,
and your light is red now. Yeah.
Light is red. Software also indicates, hey, printing has been cancelled, as you can see. Also,
where do you see that?
Oh, it says a note.
Yep.
So printing has been cancelled. I confirm in that case. And as we can also see is that the alarm light state has been changed from 1 to 3. All right.
Nice, nice.
So that is the flow that I worked on. We'll continue a little bit to the presentation. So again, my know-how in relation to program is very limited. Of course, it grew quite a lot over the last few months, but still I would say it's limited. I also had quite a basic know-how about electronics and sensorics and microcontrollers before 6 months ago. And I did this project mainly through Google and ChatGPT. So because ChatGPT, AI, large language model, writes and understands programming language also in regards to microcontrollers. So this helped me Oh, sorry, I need to a lot. So the components I used for this is an ESP32, which is like a very tiny microcontroller. I would say maybe 2 or 3 thumbs size-wise.
It's Arduino like it's Arduino compatible.
Yeah, it's very Arduino compatible in regards to libraries and using the software. Very easy of use and very cheap also. So this microcontroller goes for about 6 to 7 euros. And nice. So it's really cheap, and it has the Wi-Fi and Bluetooth integrated, which is easy, because if you want to connect to the Wi-Fi or MQTT, you need that connection. Then, of course, we need somehow a power source, so the power brick, and we need a relay, because what a relay does is just opening or closing a connection. So that's the basic functionality.
So that's the power supply to the lamp.
No, actually, the power.
Or no, not the power supply, but it's the switch connecting.
Yes. So I have 3 switches because I have 3 different states, and depending of the state that gets sent from the ESP, we'll see it later on how the connections is also built up.
Okay.
Make sure everything is compatible voltage-wise. That is at least the beginning if you need to do something with electronics. And the light itself, it's 230 volts. And therefore we're using the relay and not directly powering it, for example, through the ESP or the power brick that we have. So what does the schematics look like? I found the schematic of the light itself, and as you can see, it has 3 wires. And depending on which wire is connected, the lights start burning. And general power is done 230 volts AC. So because I have my ESP, I need to power it, which is also powered through the PSU, which is also powered by 230 volts. And this ESP needs to do something with the relay. So based on a signal that it receives, it needs to open up or close the relay. And that is the system I built. For the relay, you normally have 3 wires. You have a positive, a negative, direct current, and you have a signal wire. And this signal wire is connected to a port on that ESP and is then sending the signals itself. So that is the basic functionality.
High, low, I guess. It's just
yes.
High, low digital
signal.
Yeah,
exactly.
Okay.
Let's see.
Nice.
And then also a little bit in depth on regards to the microcontroller itself. As you can see in the middle, there is an image which shows all the ports on the microcontroller and all the functionalities of those ports. So in this case, it is connected, I think, to, it was port, do we have the, oh yeah. In my current ESP, I'm not 100% sure that the numbers are equal. It's connected to port 33, 18, and 19. So it's the pins that I connected to, which are giving the signals to the relay to open or close, and therefore activate or deactivate one of the lights. This is programmable by a micro USB, using it in your PC and using Arduino IDE software, which is open and free to use for everybody. And there are a lot of open source libraries that it can use that can help you by connecting or sending data or extracting data, for example. And you always, when you get the ESP32, the microcontroller, it's always empty. So you need to put something on there in order to start working. And as I said, I used ChatGPT to write this code. I used the prompts such as, I have an ESP32. I have 3 times a relay. It has 3 wires, positive, negative, and a signal. Please give me a code to activate the relays based on a number. And therefore, this is the basic code that I started, or the prompt that I started with. Well, it gave me a basic code. I did some testing and debugging. And after that, I said, hey, now I want to connect it to MQTT, for example. And then, of course, it starts broadening the script that you then can upload and therefore make it more interactive. So as you can see also on the left side is the interesting thing about ESP32 and the method Arduino uses is that it has open source libraries that you can use and download. And as you can see, for this project, I use the Wi-Fi because it needs to connect to
Library.
my Wi-Fi, and my UNS. And it also uses the PubSub client, which makes the MQTT communication possible. And
so the ESP32 acts as a MQTT client.
Yes, as a client.
To a broker somewhere in your network.
Yeah, so just like last time, I have locally like a tiny home server where I'm running my broker as a server. Yeah, so this only connects as a client.
And if I'm not mistaken, that server is running on a simple Raspberry Pi.
Yeah. So Raspberry Pi is also, I think, somehow connected to Arduino, which is they say a microcontroller. I think it's a single board computer would be the official term, which you can run higher, more complex stuff on. As you can see, also my MQTT broker details, it needs to be specified because it needs to be connected. And of course, I need to define the pins that I'm using, where I'm then also connecting exactly to that specific pin, the hardware, because of course it needs to have that state. And on the right side, you see also the script that it used to control the relays based on the message that it is receiving. So what is it doing? Depending if the state is 1, then the relay 1 is high, 2 is low, 3 is low. And this is how it's built up. And of course, it receives...
super straightforward.
Yep, really easy to use. So, again, I am... So that is my wrap up. I can also show you a little bit about my code and stuff like that. I'm not sure if that is still something to do, or the Node-RED flow I made.
Just quickly, the Node-RED stuff. And for this use case, maybe the sensor you connected to the same ESP, is that correct? The humidity sensor, or do you have a separate?
I have it separate.
Microcontroller for that.
So I have a separate microcontroller with a separate sensor. So what you can see over here is my Node-RED flow. Let's start on top, which gives me the humidity and the temperature that is coming from the microcontroller I have here. And it's constantly...
so that microcontroller is also an MQTT client that publishes the temperature on the broker. And this flow runs... Where does this Node-RED stuff run?
Also on my server, on my local home server that I'm connecting to. And it's good that you're saying, because so my sensor is sending out the messages. I'm extracting that from my broker through an MQTT in node. So the data is flowing in. I'm joining that data together. And then I have a function node that states if it is higher than a certain value. We can have a look inside. So it says if the humidity is higher than 65 or the temperature is higher than 27 degrees, then send a certain command or prepare a certain command. And this command is then specifically written for the 3D printer I have. So it takes that information, and if it's higher, then it will send the cancellation to my machine.
So actually very nice. I don't know if you are aware of that terminology, Lenn, but what you actually did is a clear separation of concerns, meaning you kept the microcontroller and the concern of the microcontroller as small as possible, meaning that also the Arduino logic is really straightforward and does only what it really needs to do. and you separated the actual business logic with so the decision logic, under which circumstances, what to do, you separated that and modeled that in Node-RED, and you actually run it also on another machine.
Yeah, just to have because whenever something changes, it's going to be difficult because you have to remove the microcontroller, plug it into the PC, rewrite the code, etc. So this is definitely the way to do so, I think. And then secondary, we have the state lights. So as I said, on my premise, I have now 2 brokers running, one on my central server, the other one is my printer, which is having a broker also. So what I'm doing with this MQTT node here is subscribing to the broker, which is running on my 3D printer, and then rewiring that to my broker running on my server. To get that information also into my namespace, which is this line.
So you have a centralized broker, and you use this flow in order to bridge between those 2 MQTT brokers.
Yeah. So the enterprise and the edge, so to say.
Got it.
And then, of course, it starts to extract the state of the machine, which is currently. And I have some report by exception node because I only want the information flowing once whenever state is changed. The state of the machine is reported over MQTT in a string. So I need to convert that string to a value because I programmed, as you already saw in the PowerPoint, based on number changes, value changes. And because during my startup, I have a few stages or state changes between a value that is known and a value that is not known, I did a report by exception and a delay in between to bridge that, and then set a specific state that I'm then reporting to an MQTT out node, which my light and the microcontroller inside the light is published to.
Subscribed to.
Subscribe to. Yeah. So
exactly. Okay,
whenever
nice.
this publishes, the subscribe nodes will take that value and change light color.
Yes.
That's.
Hey, and the sensor data, because actually no. So the light is subscribed to the status of the machine. Yes, of course. Yeah. And the machine is subscribed to, not subscribed. Yeah. No. Yes.
It's
and
publishing.
Business logic subscribed to the sensor. And then depending on the business decision, it will put the machine in another state as well, not only the light.
Yep, exactly. Yeah. So I didn't put too much code in here in regards to the humidity sensor, but it is really straightforward because you only use one library, and I think it's like 10 lines of code. So what Wim always asks at the end is, what did you learn from this project? So the first thing is, don't be afraid to burn a sensor or a microcontroller, because it will happen. And as you make mistakes, you learn. Be afraid to electrocute yourself, especially when you're working with 230 volts. So just to be safe, there's a lot of information available, from safety to code to how to connect my wires. And ChatGPT is not always accurate about specific libraries and sensors. So be sure that you are critical about the information that you are observing, and check sometimes between what it says and what it shows in the softwares, for example. That is the 4 main points that I want to give with. Yeah.
Great. And by the way, if it doesn't work, that's a huge learning opportunity. So,
exactly.
Yeah.
It gets easy after a while when you have done some stuff wrong.
Really inspiring use case, Lenn. Wow. I didn't know what you were gonna show, so I'm really impressed. Well
I
done.
know. Yeah, thanks. You only saw the light when it was off, so and you were
Yeah,
thinking what is gonna happen. Yep. So
yeah.
um, good. Hopefully, you
Good.
guys learned
Do
something.
you have anything to add, Len?
No, other than for me, it's a very fun experience. So,
Hmm.
and I think there is a lot to benefit of um, not only specifically using unified namespace, but trying to broaden your know-how about business automation or process automation. I think a lot of our customers can use this and help them forward. And if you can see what you can do within an hour or a few hours in automation, uh, if it is from structuring an email or just taking information out of sight of that email and posting it in a certain folder, I think there are a lot of people and businesses, at least in our customer side, that can already benefit quite a lot from those tiny automations, which are really easy to make these days. So
Yep.
yeah, that's my
Okay, perfect.
good.
Perfect. Well, I
And
have new ideas on top of this, so we will
oh,
discuss that and take the next steps.
let's do it.
Thanks a lot, man. Thanks.
Thanks. You too.
Then I
Ciao.
will close the live stream. Thank you,
Yeah,
Len.
perfect.
So the whole idea is to inspire others uh, to make the, how do you say that? To show that with a limited amount of IT knowledge or programming knowledge or whatsoever, you can really create inspiring use cases. Of course, the devil is always in the details. So to really make processes bulletproof and observable in terms of monitorable, etc., that's a whole other topic that we will dive into in upcoming videos as well. So for example, error handling and observability and deploying and having a test environment besides a production environment, all those details bit by bit we will discuss as well in these live streams. But I hope this was inspiring, and please contact us if you want to move forward with these kind of concepts. Again, in the Quotation Factory context, the whole idea is to make your shop floor as well as your CAM systems observable, such that your estimations can be improved by bridging the gap between the first estimation, the observed outcome of a simulation, and the observed outcome at the actual shop floor by connecting your machines and other types of measuring systems, such like a time registration system or a barcode reader, things like that. And by creating a closed loop system, you are able to optimize the reliability of or the correctness of your estimations, production time estimation, material usage estimation, as well as lead time estimation. And that is critical because if you overestimate, you are probably too expensive, so you sell less. If you underestimate, then that will have a direct effect on your profit margin. And in both cases, the result of the reliability of your planning will also suffer from incorrect estimations. So that's the whole idea within Quotation Factory, to really solve that problem and become a reliable manufacturing company. That's it for now. Please subscribe to our LinkedIn channel, as well as on YouTube. All the material is available. If you are interested in the Quotation Factory platform itself, just go to our website, www.quotationfactory.com, and there you can immediately get in contact with us. Nowadays we have a getting started onboarding process where you can start playing with the whole platform in less than 5 minutes. So don't hesitate. If you think this might be of high impact and high value for your business, get in contact with us, please. Okay, see you next live stream. Cheers. Have a nice day.